Welcome to my channel Worldwise. What's something people don't know about the way our universe moves? Have you ever wondered why planets orbit stars, tracing perfect paths through the vastness of space, seemingly locked in an endless waltz? Or why moons dance around planets, never drifting away, always following their parent worlds on invisible leashes? It's all thanks to a fundamental force in the universe: gravity. This invisible force shapes the motion of everything, from the tiniest speck of dust to the largest galaxies. Sir Isaac Newton, a brilliant scientist, described this force with a simple yet profound law: the law of universal gravitation. He realized that the same force pulling an apple to the ground also keeps the moon circling Earth. Imagine holding a ball and then letting it go. It falls to the ground, right? That's gravity pulling it towards the center of the Earth, just as it pulls everything else. Now imagine throwing the ball forward. It still falls, but it also travels a distance horizontally, tracing a curved path through the air. Throw it harder and it travels farther before hitting the ground, as if trying to escape Earth's pull. Now imagine throwing the ball with unimaginable force. The ball would travel so far that, as the Earth curves away beneath it, the ball keeps falling but never quite hits the ground. It would begin to orbit the planet. This is essentially how satellites orbit Earth, and how planets orbit stars. They are constantly falling, but their forward motion keeps them in a continuous loop. The star's gravity acts as an invisible tether, keeping the planet in its path, preventing it from flying off into space. The more massive an object, the stronger its gravitational pull. That's why giant planets like Jupiter have so many moons. The Sun, a star of immense mass, holds our entire solar system in its gravitational embrace, orchestrating the movement of planets, asteroids, and comets alike. Each planet, in turn, exerts its own gravity, influencing the motion of its moons, and even affecting nearby objects in space. This intricate dance of gravity is what keeps our cosmic neighborhood in order, ensuring that everything moves in harmony across the vast expanse of the universe. For centuries, astronomers meticulously charted the night sky, mapping the positions of stars and planets. In 1781, William Herschel, a dedicated astronomer, discovered a new celestial object while observing the constellation Gemini. This newfound object turned out to be a planet, later named Uranus. Uranus, a giant ball of ice and gas, became the seventh planet in our solar system. Astronomers eagerly began studying its orbit, expecting it to follow the predictable paths dictated by Newton's law of gravitation. However, as they continued their observations, a puzzling anomaly emerged. Uranus wasn't quite where it was supposed to be. At first, the discrepancies were small, easily dismissed as observational errors. But as time passed, these discrepancies grew too significant to ignore. Uranus was wobbling in its orbit, deviating from the path predicted by Newton's law. Something unseen was tugging at the icy giant, something mysterious and unknown. The unexpected wobble of Uranus sent ripples of excitement and intrigue through the scientific community. What unseen force was causing this gravitational disturbance? One possible explanation emerged. Another planet, hidden in the depths of space, might be influencing Uranus's orbit. Urbain Verrier, a brilliant French mathematician and astronomer, took on the challenge of finding this mystery object. Armed with nothing but pen, paper, and the power of mathematics, he embarked on a remarkable scientific endeavor. Verrier meticulously analyzed the observed irregularities in Uranus's orbit. He applied Newton's law of gravitation with astounding precision, calculating the mass and position of a hypothetical eighth planet that could account for Uranus's wobbly behavior. After years of relentless calculations, he pinpointed the location where this unseen planet should reside. In 1846, Verrier sent his groundbreaking predictions to Johann Galle, an astronomer at the Berlin Observatory. Galle, armed with Verrier's calculations and a powerful telescope, aimed his instrument at the specified location in the constellation Aquarius. On the night of September 23, 1846, Galle peered through his telescope, searching for the elusive planet. There, within a single degree of Verrier's predicted position, shimmered a faint blue-green disk, Neptune. The discovery sent shockwaves through the scientific world, confirming Verrier's calculations and forever changing our understanding of the solar system. Neptune's discovery was a triumph of human intellect, a testament to the power of mathematics and the elegance of Newton's laws. It demonstrated that we could unravel the mysteries of the universe from afar, using logic and observation to probe the depths of space. Neptune, the eighth planet from the Sun, is a world of icy mystery and powerful storms. Its deep blue color, more vivid than any other planet in our solar system, comes from the methane in its upper atmosphere, which absorbs red light and reflects blue. This gives Neptune its striking, almost glowing appearance in the darkness of space. This blue giant is about 4 times the diameter of Earth, a colossal ball of gas and ice shrouded in a thick atmosphere. Despite its size, Neptune is the smallest of the gas giants, but it still contains enough mass to have a powerful gravitational pull, shaping the orbits of distant objects in the solar system. Located about 30 times farther from the Sun than Earth, Neptune receives only a fraction of the sunlight that bathes our planet. The sunlight that does reach Neptune is so faint that noon on Neptune would look like a deep twilight here on Earth. Its frigid atmosphere, composed mostly of hydrogen, helium and methane, churns with some of the fastest winds in the solar system, reaching speeds of over 1,200 miles per hour. These winds are so fierce that they can circle the entire planet in just a few hours, creating a constantly shifting and dynamic environment. These winds whip up colossal storms, creating giant dark spots in Neptune's atmosphere that come and go over time. Some of these storms are so large they could swallow the entire Earth, and they can last for years before fading away. A day on Neptune, the time it takes to rotate once on its axis, is about 16 Earth hours. This rapid rotation contributes to the planet's wild weather and powerful winds, making Neptune one of the most dynamic planets in our solar system. However, due to its immense distance from the Sun, a year on Neptune, the time it takes to complete one orbit, is a lengthy 165 Earth years. That means Neptune has only completed one orbit since its discovery in 1846. Imagine celebrating only one birthday every 165 Earth years. Life on Neptune would move at a pace almost unimaginable to us here on Earth, where a single year is just a blink compared to Neptune's slow journey around the Sun. While Verrier's calculations led directly to Neptune's discovery, the story doesn't end there. In fact, the planet had been observed earlier but misidentified. Galileo Galilei, the renowned Italian astronomer, had observed Neptune in 1612 and 1613, mistaking it for a star due to its slow motion across the sky. Despite Galileo's earlier observations, Verrier is rightfully credited with the discovery of Neptune. His groundbreaking mathematical predictions, based on the observed irregularities in Uranus's orbit, pinpointed the planet's location and led to its deliberate observation and confirmation. The discovery of Neptune is a testament to the collaborative nature of science, where observations, calculations, and predictions intertwine to advance our understanding of the universe. It also highlights the importance of careful observation and the need to question even the most established theories when faced with contradictory evidence. After its discovery, the newly found planet needed a name. Astronomers and scholars debated what would be most appropriate, considering the planet's striking appearance and its place in the solar system. Following the tradition of naming planets after Roman deities, the name Neptune, the Roman god of the sea, was proposed. This tradition honored the ancient practice of connecting celestial bodies to powerful mythological figures, giving each planet a story and a legacy. The name was fitting, given the planet's deep blue color, reminiscent of the vast oceans on Earth. Its swirling azure atmosphere seemed to echo the endless depths and mysteries of our own seas, making the connection even more poetic. Neptune, the ruler of the seas in Roman mythology, was often depicted holding a trident, a three-pronged spear. This symbol represented his dominion over the waters and his immense power among the gods. Coincidentally, the astronomical symbol for Neptune is a stylized trident, further solidifying the connection between the planet and its namesake. This symbol is now recognized by astronomers and enthusiasts around the world. The discovery of Neptune marked a pivotal moment in astronomy. It was the first planet found through mathematical prediction rather than direct observation, showcasing the growing power of scientific reasoning. It not only expanded the boundaries of our solar system but also demonstrated the power of mathematics to unlock the secrets of the cosmos. Neptune's discovery inspired generations of scientists to look beyond what is visible and trust in the unseen. It serves as a reminder that there's still so much more to discover, hidden in the depths of space, waiting for the next curious mind to unravel its mysteries. The story of Neptune encourages us to keep exploring, to keep asking questions, and to never stop seeking answers among the stars. My next video watching now.